You can let me do my thing.
Okay, good.
I have to justify my presence here. So hello everyone, and thanks for joining our webinar on Qt 3D Studio. I have a little something planned here, like there it is. To get you off right, this is your host Patrick Oxlin with our expert Sami Makkonen. Say hi, Sami.
Yeah, hi, my name is Sami Makkonen. I'm the product manager for the Qt 3D Studio in the Qt company.
So thank you. So just before that, Sami will have his presentation. Afterwards, we have a short Q&A session. So there's that. If you have any questions, please submit them by the question box at the bottom of the interface, and we will try and answer them towards the end. Now, don't take this as an excuse to skip class, but this webinar will be recorded and you will receive a copy of it along with the slides delivered to your email account after the webinar has ended. But yeah, enough out of me. I will hand it now over to you, Sami, and hope you all enjoy it.
Okay, thanks. So the idea for this webinar was that we would go through a short introduction, so a couple of slides about what Qt 3D Studio is and what it isn't, what you can do with it, and what are the kind of main features and main benefits for using Qt 3D Studio. Then let's actually dive into the tool itself. So let's look at the basic concept of the user interface and how do you do stuff. So the idea would be that I'll give a short live demo on creating a small user interface with Qt 3D Studio. And then we would dive into actually a bit of coding or at least looking at code, so that how do you actually integrate the Qt 3D Studio user interfaces that you have created to the Qt-based application. How do you use the Qt Quick API to integrate, for example, functionality or data coming from different sources to the user interface. Then a couple of slides, how to get started, where do you find information, and then also kind of a couple of words about the releases that are coming in the near future. So what do you expect in the future releases with Qt 3D Studio? If we start with the basic and the history, Qt 3D Studio was actually an application contributed by NVIDIA to the Qt project. So it has a long history. NVIDIA was developing the tool for creating embedded user interfaces for their hardware platforms. And then they decided that it would be getting a bigger audience if they contributed that as part of the Qt project. And already NVIDIA had created Qt bindings to the tool. So Qt was used already in actually making also the tool, but also the kind of the technology to create applications with the user interfaces created with the NVIDIA Drive Design Studio, as it was called earlier. And of course, this was something that was basically missing from the Qt itself. We do have, for example, Qt Quick Designer for making 2D user interfaces, but for 3D user interfaces, we didn't really have a proper tooling before. So this tool actually now lifts the tooling part of the Qt 3D offering on the whole new level. And of course, it wasn't originally created for Qt, so now we are doing the integration to the Qt tooling and also improving the Qt APIs so that you can interact with the user interface even easier in the future. And if we look at the key benefits, of course, it's the kind of what you see is what you get design, so that you don't have to design the user interface by using coding the user interface. So you can do that by using the tool. And of course, also deploying that user interface as soon as possible to the target device, so that, for example, if you are targeting to a mobile device or embedded device, you can use our tooling to directly deploy that user interface to the target device, so that you see that if there are some, for example, performance issues on the target devices, or some of the effects, for example, are not working in that OpenGL version that the device has. So you can get the issues that you would be facing in the end result visible as soon as possible. And of course, being integrated with Qt, you get all the goodies that Qt has to offer. So Qt is a vast library of multiple functions. So you can integrate with the databases, network services. You can deploy application to the desktop, mobile, embedded. So all the benefits that Qt brings into the table. And also one of the main principles in developing the Qt 3D Studio is its open architecture, so that you can extend the functionality by using the existing plugin APIs. You can create your own materials, effects, if you want. And of course, being part of the Qt, all source code is available, so that you can look how the implementation was done, so that this application and the runtime engine is not a black box, so that you can get into the details of how this has been implemented and how stuff works, if you want to go into the details. Main features for Qt 3D Studio. So Qt 3D Studio is not as such a 3D design tool. So basically what you do with the Qt 3D Studio is define the look and feel of the user interface, so that you import your 3D assets that you have created in one of the some of the 3D design tools, whether it's Maya or Modo or Blender. And in those tools, you export the 3D assets as FBX or Collada formats, and then you import those 3D assets to the Qt 3D Studio. Then you can start working on the animations, so that how do the 3D objects move in the user interface by using keyframe animations. And also you can create these animations dynamic, so that, for example, if you have user input and the user wants to interrupt an animation, it can do that dynamically, so that it continues from the animation that it's running at the moment and then moves into another animation smoothly. So this is one of the really cool features in the Qt 3D Studio. There's also layered rendering, so that you can create different layers in the user interface. So basically this is really similar functionality as you have in the, for example, in Photoshop, so that you can create different layers and then also define how those are composed into the user interface. Then we have the user interface stage, which is called slides. Again, this is pretty similar functionality as, for example, in PowerPoint, so that you have some stuff, for example, that are visible in the user interface for all of the time. And then you have different states that, for example, some objects are taken away from the UI, or they are animated into a different location, or you can actually change the whole content of the UI in different states. Then there's components and sub-presentations. So basically components are components that you include to the user interface, and they have their own timeline. So for example, if you think about, for example, car instrument cluster, you have a couple of cages in the user interface. Those cages can be components, and you can animate those independently from the main user interface, so that, for example, you can have a cage needle showing the speed of the car, and that is animated with the separate timeline to the other user interface, so that, for example, you can tilt the cages and still the animation for the needle is running. And then there's also a functionality called sub-presentations, which is basically mechanism for including external presentations. So that, for example, if you have a project that has several different components, you can have different people working on different parts of the user interface, and then you just basically combine the components into the main user interface, so that using these sub-presentations. This is really handy for dividing the work between the teams. Then we have post-processing effects. So these are effects that you can apply to the user interface, meaning one of the layers in the user interface. And you can use these, for example, creating different kind of highlighting to the user interface, or just creating a kind of a particular style in the user interface. For example, using different colors and using the depth of field, so that you can, for example, highlight the user focus in a certain point of the user interface. Then a couple of words about the hardware and software requirements. So basically what we have is two parts. It's the editor part, which you use for creating the user interface in your PC. The editor part is operating in either in Windows, in Mac, or in Mac. Those are the ones that we are releasing as binary releases at the moment. Then also desktop Linux is supported, but at the moment you have to compile the Linux build yourself. But Linux is supported as such. So this is the benefit that you get from creating the user interface with Qt. And then we have the runtime part, which is the component that is actually running the application in the end device. At the moment, we are requiring OpenGL ES 3.1, but also ES2 is supported. But of course, the feature set is reduced because OpenGL ES2 doesn't support all of the features that the runtime has. And of course, we are targeting to the desktop environments, mobile environments, and also embedded environments. So that meaning that embedded Linux is supported, QNX and Integrity are supported as well from the embedded side. And in the mobile side, Android is supported at the moment. Unfortunately, iOS is not yet in the supported platform list at the moment. But actually, now let's dive into the actual user interface and the editor part. So let's have this as the kind of live presentation part. So that when you create a new project with the Qt3D Studio, this is what you see. A new presentation that doesn't contain anything. So that what you have is basically camera and light, but you don't have any objects in the user interface. You can modify the presentation settings, so that, for example, if you know that the target device has a certain resolution, you can change that from the presentation settings, and then you can click fit so that the presentation fits into the editor view. And then you have some basic objects here, for example, rectangles, spheres, cubes on the top right-hand side of the user interface. You can start tracking basic components in the user interface, and then those will be added to the timeline, so that you have the cylinder object here, and it has a default material, so that which defines how that looks. On the top, you have the menu bar that has the manipulators, so that you can move the objects in the view. You can scale them in each of the direction or the whole object. And of course, rotation is also included. So all the basic manipulators that you have for the 3D objects. And also at the bottom part, you can see the values. So for example, the Z rotation was something that was changed, and you can see the value changing here. And same applies, of course, to the other properties as well. And then on the left side, you see the slides, meaning the user interface states, and we have the master slide, which is again pretty similar as you have in the PowerPoint, so that everything that is visible in the user interface all the time, or at least almost all the time, should be placed into the master slide. So basically it's the kind of the user interface template, and then with the individual slides you can define different stuff to the user interface, and you can animate the stuff that is also in the master slide. So this is, in that sense, it's a bit different from the PowerPoint. But if we go into the master slide by activating the edit master slide, we can see that actually now the cylinder that I just added to the user interface is not visible in the master slide. So it's specific for the slide 1 that was visible when I was dragging the object to the user interface. Then in the timeline view, we have basically everything that is included into the project. And we have the timeline, and you can, for example, set also the visibility of the object in the user interface. And then you can create animations by activating different properties to be animated. So basically in the menu bar, you have auto set keyframes, which means that this is basically doing recording of your movements in the scene. So that, for example, if I would like to animate this cylinder moving from one side to another, I could activate the position, and it automatically creates a keyframe to the timeline. And then I decide that, okay, my animation is 3 seconds long, and then I go in the timeline to the 3-second mark, and then I can modify the value where I want the animation to be going, and it automatically creates a keyframe to that direction, that point of time. Then you can see that, okay, when I scrub the timeline marker, then you can see the animation happening. But actually, let's start working with some 3D objects. So that let's delete the cylinder and actually edit the master slide. And let's go into the project assets. So basically, this is a file system structure for the project I created, so that it has empty directories for effects, fonts, maps, materials, models, and scripts. And basically, what I start doing is filling this structure so that I'll start dragging stuff from 3D design tool to the project. And actually, I was browsing the directory or catalog that latest Windows version has in the Paint 3D object. So basically, latest Windows 10 version has a new software called Paint 3D, and they also have a library for 3D models. So I basically browsed this catalog, and there was this phone model that I have visible here, and then you can import that into the view in the design tool here in Paint 3D, and then you can actually export that object as FBX file. So I did that, and that produces an FBX file I can use in my project. So if we go to the project, and we are now in the master slide, we can drag the FBX file to the models directory here. And what it creates is an internal presentation of the FBX file, meaning that it has a mesh file, meaning the geometry of the 3D object, and then it also has a couple of textures coming from the original design. And then there's an import file, which is basically a description of the imported object. And I can now drag that into the view. And actually, you can see that it now imported, but you can't basically see anything. You see that, okay, the object is here and the material is here, so something is wrong. And actually, in this case, the size of the object defined by the 3D design tool is quite small. So actually, by increasing the scale of the object, you can get it visible. And it has imported also the textures for the object. Then you can take a look that, okay, now we have the object. We can see that the pivot point of the object is actually behind the object. We can fix that later on. But moving back to the camera view, you see that this is the way that the user sees the object when it's displayed in the application. Then I can see that, okay, it has created the material coming from the design tool. It has a diffuse map and the specular reflection map. I can, for example, take those away, and you can see the plane geometry for the object in the view. And then, of course, I can rotate the object, and as you can see, the pivot point is a bit behind the object, and I can change that so that you can get it closer, so that all the animations that you're actually doing are then done with the correct place. So this is now pretty much in the correct location, so that when you now rotate, you can create this kind of rotation animations. Then we can, of course, change the materials and change the, for example, the textures, so that if you don't want to use the textures that were included in the project, you can import other textures. Or you can define, for example, the base material so that they look different, so that, for example, you can change the color of the diffuse. So that, for example, if you want to have a green phone, you can change just the parameters of the material here. And all of these are such that you can animate, and all of these that are marked with the stopwatch are also properties that you can change from the Qt application during the runtime. Then we can also add stuff, so that, for example, let's add a new object for example, the screen, so that we can have, for example, a mock-up of the user interface, so that I can drag that into the project and then activate that. And here we can see that actually the scale is quite big, so that changing the scale, and also the position seems to be now that it's back behind the object. And then I can, of course, use the manipulators to get the correct location of the object. And if I use the perspective view, I can see that, okay, it's almost next to the phone. And then in the scene camera view, let's make the final adjustment, so that you pretty much have the UI located into the view. So something like this. But of course, now if you animate or rotate the phone, of course the new object is not included, so that they animate separately. But I can actually create the group, so that I can create the grouping object, so that I can put the phone into that group and also the UI into the same group. And when I modify the properties of the group, for example, the rotation, now they both change at the same time. Then I can also, for example, add different kind of effects, so that, for example, let's use, for example, here a small reflection, so that we can open up the maps library that is included in the application, and open the specular reflections and add that to the user interface, and define that to the, for example, to the phone object material, so that let's add a specular reflection and use the map that we just added, and then change the diffuse color of the object a bit, so that you can actually see the reflection. Now we have been operating in the master slide for the whole time, meaning that all the objects are visible in all of the slides, so that when you create a new slide, it has the same content as the master slide. So the phone and the phone user interface are included in the master, both of these slides. But then I can start creating animations, different kind of animations, so that, for example, if I make a spinning animation, I can create a new state for that, meaning new slide, and then define that, okay, the whole animation or the whole timeline, it takes 3 seconds, and then I can make a 2-second animation to the phone group, so that, for example, let's create the rotation animation. And then I need to unlink from the master slide, so that this is happening, this animation is happening on this slide only. So that the master slide is not animating for this object. Then I again set the keyframe for the first animation keyframe, and then I change the values so that I want to have full 360 degrees, so that we can see that the animation is now animating the phone 360 degrees, and the animation lasts 2 seconds, and then the whole timeline for this takes 3 seconds. So if we want to preview this in the viewer part, then we can see that now the phone is animating and then stops for 3 seconds. We can change the play state so that, for example, if you want to have the animation looping, then you can define that to the scene. So that when I now run the animation, it animates in 2 seconds, it stays still for 1 second, which is the length of the timeline, and then continues animation. Hopefully you can see the animations okay through the webinar system. Then you can also define the anti-aliasing methods used in the layer, so that you can get the phone looking smoother by changing the anti-aliasing. Then we can go to another slide. We see that, okay, this doesn't have any animation, so we can define another animation, so that again the rotation is animated, so that let's again create a 2-second animation, or actually let's make a shorter one, 1 second animation, and animating the rotation of the phone so that it tilts to the portrait. And then we can name this tilt right. And then if we define that now the slide is looping, then we can define that it's actually play through the next slide, or we can actually say that play through the to tilt right. So if we now let's also move the timeline a bit shorter, so we can see that if you play this animation, then it plays these 2 animations in a row. And then we can do another animation so that it's actually tilting the opposite direction. Again, let's create the 1 second animation. And now we can drag the value or set the value from the user interface so that it's tilting the other way around. So now we have 3 animations for tilting the phone and spinning the phone. And then we could actually also create a kind of a new slide for the base portrait. So let's just create so that this is basically staying portrait for the whole time. So this is the quick introduction of how you create the project, and then of course now the user interface doesn't have any controls. So let's quickly dive into the Qt side of things. So let's open Qt Creator, and I have already created the small project that contains the user interface, 2D user interface part for controlling the application. So this is pure QML application, and it has a Studio 3D element, which is the way that you integrate the 3D user interface part to the Qt-based application. And then we have a small menu that has a couple of buttons designed with the Qt Quick Designer. So basically you have tilt right, tilt left, and spin. And then you have a couple of buttons for changing the colors of the phone. And in the Qt project, you have to include the 3D user interface part by creating a new resource file that you use to deploy the 3D part of the user interface. So let's create a new resource file, Qt 3D UI, and add that to the project. And then you basically need to add the 3D user interface files that you created. So this is the structure that you created with the Qt 3D Studio, and you can see that there's a couple of project files, meaning the UIA and UIP files. Add all of these to the project, and now they are usable in the project. And in the main application, you basically define in the Studio 3D part that how big part of the user interface the 3D part uses. So actually I'm putting this now here, filling the whole user interface, and then defining that it's centered vertically. And then I can define, for example, the scaling mode for the 3D user interface by setting the viewer settings. But then we have actually missing the part of the linking, the 3D part. So basically what I need to include is the copy the URL of the UIA file and add that into the project like this one. And if everything goes smoothly by building the application, okay, now I'm introduced an error. Okay, so actually I have introduced an error in the application. So the application doesn't compile. I think that we have to rebuild because this was something that I used for testing. And now let's actually also delete the build directory. And now the application is building. And now in the user interface, you can see the 3D user interface integrated, and the animations were defined so that it was actually spinning first and then playing through the tilt right animation. And also the menu that I had created was visible in the user interface. Then I can control the 3D part of the UI by referencing to the phone object, which is the presentation that I just created or added to the user interface, so that you can see that the idea here is a phone. And then with the command go to slide to scene and tilt right, I can go into the tilt right slide of the user interface. So in the menu, when you press the tilt right, then the user in the 3D user interface goes to the tilt right state, and same for the tilt left and the spin. So that actually, if we run the application, we can see that it actually also changes the state of the UI. And now that these animations haven't made dynamic, it always starts from the beginning of the animation. But if we actually go to the animations here, so that, for example, the rotation animation, we make the animation dynamic, and also for the tilt right, set the keyframe and make animations dynamic, and save the project. And when I compile the application again, you should be able to see the difference in way that it continues the previous animation, so that it smoothly continues from the animation state that you were in. So this changes the behavior of the animation by making those animations dynamic. But of course, you have to see that what's the current way of animating between the user interruptions. Then we can also define elements in the user interface, so that, for example, we have the foam material that we want to change from the application side, and we need the element path from the user interface, so that we know that this is the material that we want to modify the color, so basically the diffuse color. So we can use the copy object path from the Qt3D Studio side, and then copy paste that element path into the QML code. And now, after that, we have an object that we can reference as the phone material. And in the menu, I have defined that the buttons pink and blue have the on pressed, and it's taking the color from the rectangle that was in the user interface, and sets the color values from the color that is in the user interface. So that when I run this application again, I can actually change the color of the phone by using these two different buttons. So this was a short introduction on how you can modify stuff from the QML side. And all of these properties that are, for example, the phone has rotation, scaling, pivoting, all the textures. For example, if you want to change the texture of the object during runtime, you can also do that from the QML application side. Then one thing to note also for the integration is actually that you can also stream Qt Quick user interface to the 3D object surfaces. So that, for example, if you have, for example, this user interface in the 3D UI could be implemented with Qt Quick, and then you can place that dynamic user interface as the texture to the phone, so that you can actually create a 2D user interface and put that on top of 3D object, and basically it can be everything that Qt has to offer for example, if you want to play video stream on top of the 3D object, you can do that by just creating a video element in the Qt Quick application and streaming that content as a texture on top of a 3D object. But I think that that goes a bit beyond this presentation, and it would take a bit of a tinkering. But please remember that that's also an option that you can use Qt Quick to create the textures for objects. So if we basically skip these slides that we just went through in the live demo, and these are the QML APIs that you can use, but the documentation is online and also, of course, included into the installation of the Qt 3D Studio. So you can take a look of the API in the documentation. And if we look at the timeline, this is how the project has been going. So first release was done at the end of last year, and now we are working with the 1.1 release, which is basically introducing a new data node concept, which is an easier way to pass data from the Qt Quick application to the 3D user interface. So basically what you do is define different data nodes that you can use throughout the 3D object. So it's basically an extension to the API that we have at the moment. And then, of course, some minor fixes and tweaks for the user interface. And then we are also working simultaneously for 2.0 release, which actually brings a bit bigger change under the hood, which is basically replacing the 3D rendering engine, so that the engine that we at the moment use, that was contributed by NVIDIA, is now changed to the Qt 3D based runtime. So Qt 3D is a 3D library or 3D engine that has been included in the Qt for some time now already, and it's a really powerful and multi-threaded 3D engine, and really flexible in creating different kind of frame graphs. So basically we are replacing the existing NVIDIA engine with the Qt 3D based. But for the user, this shouldn't be anyhow visible. So this is something that is happening under the hood. And then, of course, working all the time with the new operating system support, so meaning the real-time operating systems and testing on different hardware. So the runtime is highly portable. Both 1.0 and 2.0 runtimes are highly portable. But basically what we are doing is increasing the testing in different hardware and operating system combinations. And how to get started with Qt 3D Studio, if you already haven't, is to get, of course, the application either through online installer if you already have installed Qt with the online installer. So you can add the Qt 3D Studio. If you're commercial customers, you can go to the Qt account, and in the download sections you can get the standalone binaries installer for the Qt 3D Studio, and of course this is also available in the download section of the Qt IO pages. Documentation is actually now also in the official documentation, so that and the latest is in the doc snapshots. So, but going to the Qt IO web pages and to the documentation, you can find the Qt 3D Studio documentation from the main page. And then we have also released a couple of demo applications in a separate Git repository, so that there's a public demos and Qt 3D Studio in the Git Qt.io repository. And also there are some examples included in the installation package. So just go to the installation directory and examples folder, and you can see some really basic examples how to get started and using different features of Qt 3D Studio. So this was my presentation. So I think we have some time for the questions.
Impressive stuff, Sami. That was great. It's a regular little introduction on how to get started into Qt 3D Studio. I feel like I've learned something myself. Just a question, you talked a bit about QML, etc., and I think we may have some maybe non-developer people listening into here, for example, who work as or more into UI development or UI designers. What are exactly the requirements in terms of programming knowledge to use Qt 3D Studio?
Yeah, so basically you can define the look and feel, and you can define the animations, and you can define the transitions, and you can also actually create actions, so that, for example, you can actually create the buttons, for example, also in the Qt 3D Studio, and then you can hook up actions to the buttons that you have created. So you can actually create the whole user interface without any coding. So basically the QML side of things is something that you do when you integrate the user interface into the end applications. So that, for example, if you have some values, for example, coming from different sensors from the device, then you hook those sensor data to the user interface by using C++ and Qt Quick. So no coding is required for creating the user interface part. And same applies if you are creating a 2D user interface. You have the Qt Quick Designer that I briefly showed, so that you can use that to define the 2D user interface without any coding.
All right. So next question I'll take from Björn, who asks, is it possible to leverage this inside C++ and not just Qt Quick?
Yeah, there's also a C++ API for the Qt Quick Qt 3D Studio, so it is possible.
John Val asks, when will Qt 3D Studio support Vulkan? Any plans?
Yeah, actually, that's a good question, in a sense that already the 1.0 engine is also, the rendering is independent, so that you could create different kind of rendering pipelines, but it's actually, all the shaders are heavily based on OpenGL. So it's basically the whole application is running on top of OpenGL. But as you might know, the Qt 3D already has some support for Vulkan, and it is built so that it's not tied to OpenGL. So in the future, definitely this could be something that we are doing, but at least for the 2.0, it hasn't been committed. So basically what we are now doing is taking the existing OpenGL shaders and putting those on top of Qt 3D. So in the future, possibly, but not at the roadmap at the moment.
Is Qt 3D Studio fully supported in QNX 7.0?
Yeah, we are running example applications in QNX in, I think, at least a couple of different hardware architectures.
And we have Nikita asking about performance. I've seen 25 frames per second, but can it be more? Just a quick something I should probably mention is that the webinar tool we're currently using isn't too fluid. So if something looked a bit choppy, that's mostly because of the webinar tool we're using currently. We're trying to swap to another one, but in the meantime, this is what we're working with. So Sami,
Yeah, definitely 60 FPS is the target for all of the user interfaces, but of course it depends on the user interface that you are creating and the device that you are running into. If you saw that the FPS numbers in the debug that I had, that's exactly because of the webinar running simultaneously. I was running a debug build, and then but actually that user interface is running Fluence 60 FPS in the machine. And of course, you can kill the performance in many ways when you are creating the user interface, either by using, for example, really huge textures or using highly detailed 3D models, adding a lot of post-processing effects to the user interface, and then using hardware that isn't capable of running that kind of user interface in the first place. And that was the reason why I highlighted that early device deployment is something that you should do and you should constantly do, so that you can immediately see that, okay, now I added one effect, or I added one new 3D object into the scene, and suddenly the FPS drops dramatically. So you catch those issues early on. And we also, in the viewer, we have, for example, to the Android, we have released a viewer in the Google Play Store, so that you can install that to, for example, Android tablet and remotely deploy from the editor application to the Android tablet. So basically you just have to have those two in the same network, and you can remotely deploy directly to the device. And of course, same applies if you have an embedded device. So basically you just compile the viewer application to your target device, and you can use that to debug these kind of performance issues.
All right. We have 3 more minutes, so let's have a few short fire questions. Let's see, Marty has 2 of them. Is there any shader tweaking integration with Q3D Studio?
Yeah, you can actually tweak the shaders so that the materials and effects, the shaders are included as part of the code, and they are actually also in the folders that you when you create the project, it copies the needed shaders to the project, and you can modify those shaders.
What about triggers in the What about triggers in the 3D scene? Can we create those?
Yeah, you can create objects and create actions. So that was something that I didn't show when creating the project, but you could create the 3D object and hook an action to that object, so that it, for example, changes value or goes to the next slide or whatever you want to do. But it is possible. I just didn't show that in this short demo.
Saif asks, are there any plans for iOS support?
Yeah, definitely want to be cross-platform. So iOS is also in the plans and in the works, but unfortunately not yet supported. And hopefully we can have it in the 2.0 release available.
Also saw a question about that if you switch from a 3D program to Qt. So in essence, if you're exporting assets to Qt from a 3D program, if textures, animations in said 3D program would be imported, like textures, light, animation, how do those preserve?
Yeah, animations can be baked into the exported file, and those can be imported. And so it is possible to create the animations in the 3D design tool. But it's a kind of also that if you then change the animations in the 3D Studio, then the kind of the going back to the 3D design tools, there's a functionality to refresh the import, so that so it's not only one shot import, so you can refresh the import. But if you heavily modify the original file, then it might cause some issues. But yeah, animations are possible to import.
All right, it's 10 o'clock, but we're going to squeeze one more last question in from Angel, who has a very existential question. What type of applications can you create with Qt3D Studio? Or what is the whole purpose of having Qt3D Studio? So if you could just have your top 3 use cases.
So basically, it's 3D user interfaces. So if you have pre-existing 3D objects that you want to animate and show in the user interface, and you want to control those from the Qt-based application, that is the base use case that you use. For example, if you have some generated 3D objects, so that, for example, you are taking some sensor data and you need to create 3D geometry out of the data, that is not yet supported. So basically, it's predefined content that you create in the 3D design tools, and defining the look and feel in the real-time rendering engine, so that it looks the same in the final application. So that basically you are taking the assets that you create in the 3D design tool and making those real-time rendering engine, running those in a real-time rendering engine inside your application. So that's the use case.
All right, anything we didn't go over that you would like to add?
Yeah, I think that I hopefully conveyed a picture of what you can do, achieve with the Qt3D Studio, and hopefully it was also kind of how easy it is to start prototyping with the user interface and fluently kind of change between different animations, and also, for example, configuring the look and feel for the user interface.
All right, that was a lot of questions. You're a great crowd. And just let me see what I have to go with. So if you have any more questions, though, you can send us an email to info@qt.io. Alternatively, you can also ask them during our other Qt3D Studio webinar, which will happen this Thursday. Also tell the people you love that have missed this first one about this webinar, so they can join and be part of the fun. Next week's webinar is, however, by none less than our Senior Vice President of R&D, Tuukka Turunen, and he will tell you how the new Qt Safe Render lets you create functionally safe systems. They comply with all kinds of IEC and ISO standards. So this should be super interesting for those of you who work in the industrial, automotive, medical, and really all other industries that rely on safety and bulletproof application. Don't forget to visit our website, qt.io, where you can find all kinds of information. And don't forget to fill in the survey at the end. It will help us to improve our webinars, and let us know if there's any particular topics you would like to hear about. So we can get a few ideas and get an idea of what you would like to hear about. But this will be it for today. Thank you all so much for joining and being such a great and active crowd. And we wish you a great day. And until next time, take care.